In this video, I'm going to demonstrate how an optimal decision is reached in a situation where there is a limiting factor. A limiting factor is a resource or any factor of production that sets a limit on the production we can make or the quantity that we can produce. So let's go through this question. Cocoa Limited produces 4 different types of tables. The production manager is preparing its production mix for the year and has presented the following. You have type of table A, B, C, D. You have the selling price per unit, material price per kilogram, labor hour rate, material requirement per kilogram, labor hour requirement, and maximum demand. Assume that materials are limited to 59,600 kilograms and labor hours are limited to 48,000 hours. Required: advise the management on the most profitable mix of production. Compute the total contribution the company would earn from the production mix determined in I above, and the maximum profit if Cocoa Limited incurs fixed cost of 800,000. To make up for the excess demand, a subcontractor has approached Cocoa Limited for the supply of the table whose demand the company cannot fully meet, given the limiting factor. He offers to supply the tables at a price of 180 Ghana cedis per unit. As a management accounting consultant, advise Cocoa Limited on whether or not to accept this offer. Alright, so like I said earlier, a limiting factor is that resource or that factor of production or that input that sets a limit on the number of units a company can produce. Okay, in the question we are told that materials are limited to 59,600 kilograms and labor hours are limited to 48,000 hours. Because we have 2 resources, we have to determine which of them sets a limit on the quantity we can produce. So the first thing is to determine the limiting factor. So determination of limiting factor. Because we have 2 resources, we have to determine the total resource requirement for each of the resources. So first of all, we are determining the total material requirement for the entire demand. So first, determination of total material requirement. Underline it. Okay. We have 4 different types of tables: A, B, C, and D. And then we have a demand in units. Let's go back to the question. We are told that the maximum demand for A is 1,500, B 1,002, C 2,000, D 2,000. So we have 1,500 here, 1,200, 2,000, and another 2,000. In order to determine the total material requirements, we have to multiply the demand by the material required per unit. So material required per unit. These are in kilograms. So let's go back to the question. We are told that for table A, the materials required are 10. And for B, we have 8, C, 10, D, 12. So we come and write them here. 10, 8, 10, and then 12. Now we multiply them vertically to determine the total material required per demand. Total material required. So we multiply 1005 by 10. That will give us 15,000, meaning that we require 15,000 kilograms of materials to manufacture 1,500 units of table A. For B, we have a total material requirement of 9,006. For C, we have 20,000. And for D, we have 24,000. So summing up all of them, it means that the total material requirement in respect of all the tables is the summation of the total material requirement for each of the tables. So we add 15,000 to 9,600, 20,000 and 24,000, and you get 68,600 kilograms. So Coca-Cola Limited requires 68,600 kilograms in order to meet demand for all the tables. But then we are told that we have only 59,600 kilograms of materials. So total materials available go to 59,600 kilograms. So when you subtract the total material required from the total materials available, we have a shortage of 9,000. We have a shortage of 9,000. Okay. Now, let's determine the total labor hour requirement because it is the other resource we have. So determination of total labor hour requirement. Again, we have tables A, B, C, and D. So A, B, C, and D. To determine the total requirement, we multiply the demand by the labor hour per unit. So the total demand or the maximum demand in respect of table A is 1,005. Table B, 1,002. We have 2,000 for C and 2,000 for D. So we multiply it by the labor hour required per unit. let's go back to the question. Realize that for table A, we require 8 hours, B 10 hours, C 6 hours, and D 4 hours. So we fill that in. We have 8, 10, 6, and 4. And now we multiply vertically. So in respect of table A, we require total labor hours of 12,000. That is, when we multiply 1,005 by 8, we get 12,000. And for B, we require 12,000 labor hours. For C, also requires 12,000. And for D, labor hours of 8,000 are required. So again, we sum up all the requirements and we get a total labor hour requirement in respect of all the tables. To be 44,000 hours. And now we are told that the labor hours are limited to 48,000 hours. So we have available labor hours. We have 48,000 hours of labor available. So when you subtract the requirement from the available hours, we have a surplus of 4,000 hours. Because there is a surplus of 4,000 hours, then labor hour is not the limiting factor. Materials are the limiting factor because there is a shortage of 9,000 kilograms. This is a shortage. Once we have been able to identify the limiting factor, then now we go on to compute the contribution per unit. So computation of contribution per unit. Okay. So how do we find contribution? We know contribution is found by subtracting the variable cost from selling price. So again, we have tables A up to D. So table A. We have table B, table C, and table D. Bring our Ghana city sign here. Okay. So like I said earlier, contribution is selling price minus variable cost. So we have selling price here. Let's go back and check the selling price for each table. For table A, we have a selling price of 440, table B 380, 320 for C, and 260 for D. So we have 440 here, 380, 320, and 260. Then we will less our variable cost. In this question, we have two variable costs. We have material cost and then labor cost. So material cost. We also have labor cost. Going back to our question, we realize that the material price per kilogram is 10 Ghana cedis. So in respect of table A, each material will cost 10 by the total material required for A. So we multiply 10 by 10 to get the total material required for A. If we get to table B, we multiply the same material price per kilogram of 10 by the material required of 8. C, we multiply 10 by 10, and then for D, we multiply 10 by 12. So in respect of material for table A, we have 100. For table B, we have 80. For table C, we have 100. And for table D, we have 120. Then let's go and look at our labor cost. We are told that we have labor hour rate of 5 Ghana cedis per hour. In respect of table A, it requires 8 hours to produce. So to calculate the labor cost per unit of A, we multiply 5 by 8. So 5 times 8 for A. Then for B, we multiply 5 by 10. For C, we multiply 5 by 6. And for D, we multiply 5 by 4. So A, when we do the multiplication, we have 40. And for B, we have 50. For C, we have 130. And for D, we have 20. So when we sum up, 100 plus 40 will give us 140. $80 plus 50 will give us 130. We are going to less 100 plus 130. Sorry, this is supposed to be 30. So 100 plus 30 will give us another 130. $120 plus 20 will give us 140. So that is the total or the variable cost per unit. We are going to subtract that from the selling price to calculate the contribution. So in respect of table A, we subtract 140 from 440 and that gives us 300. For B, we subtract 130 from 380 and that gives us 250. For C, 130 from 320 will give us 190. And then for D, 140 from 260 will give us 120. So these are the contributions per unit. Okay. After determining the contribution per unit, now we determine the contribution per limiting factor. So we have computation of contribution per limiting factor. Okay, so again we have 4 tables. We have table A, B, C, and D. A, B, C, and D. Okay. We have our contribution per unit. In Ghana cedis. These are the figures we just calculated. So in respect of A, we have contribution per unit of 300, B, we have 250, C, we have 190, and D, we have 120. So we have 300, 250, 190, and 120. Now we know our limiting factor. The limiting factor here is material. So we have material requirement per unit. So material per unit, which is in kilograms. The material requirement per unit for table A is 10. So that's 10 kilograms. For B, we have 8. For C, we have 10. And then for D, we have 12. These were given in the question. So now we compute our contribution per limiting factor, which is the material. So contribution per limiting factor. We compute that by dividing the contribution per unit by the material per unit. So for table A, we divide 300 by 10, and that gives us 30. For B, we divide 250 by 8, and that gives us 31.25. For C, we divide 190 by 10, that is 19, and for D, we have a contribution per limiting factor of 10. Okay. After computing the contributions per limiting factor, we have to rank them, or we have to order them. So we have our ranking here. We rank them from the highest to the lowest. So on comparing them, we realize that the contribution per limiting factor for B is the highest. So it has a rank of 1. So it's the first. Then it's followed by A, which has 30. And then the third one is C. Finally, we have D. So after ranking them, we now prepare our optimum production plan. So that was the first requirement. Preparation of optimum production plan. The name of the company is Okukroko Limited. Okay. So we follow a particular pro forma in preparing the production plan. So first we have a type. So type of table. Then we have materials available. And we also have material usage. We have remaining materials. We have cumulative material usage. and then we have our output. The materials available are in kilograms, so usage kilograms, 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 but the output is in the form of units of tables, so we have units. We are going to prepare our optimum production plan according to the ranking or the ordering we did. So let's go back. The table with the first rank is table B. So we are going to produce table B first, followed by table A, followed by table C, and finally table D. So first rank is table B. Okay. We are told the total materials available according to the question is 59,600. And then the material requirement for table B. Let's go back. For table B, we have a material requirement of 9,600. So that is 9,600. We subtract the 9,600 from 59,000 and we get 50,000 as the remaining materials. That is, after using 9,600, we have 50,000 as the remaining one. Then the cumulative material usage is the total number of material spent so far. So because we've used 9,600, it means we've spent 9,600 so far. If we spend 9,600 or we use 9,600 in producing material B, then it means we are going to produce the total number of units required of 1,002. Okay, so if you use 9,600 materials, we are going to produce a demand. We are going to meet the demand of 1,002. So we have 1,002. The 9,600 corresponds to the total demand of 1,002. The second on the ranking is is table A. So we have A. Now the materials available. The materials available is calculated by taking the remaining materials. So we had remaining materials of 50,000 after producing B. So now the materials available is 50,000. Then we are going to subtract the materials we are going to use for producing A. When we refer back to our material determination schedule, we have a material usage of 15,000 in respect of table A. So when you subtract 15,000 from 50,000, we are going to get 35,000 as the remaining materials. So that the cumulative materials used, that is, we are going to add the 9,600 to 15,000, and that will give us 24,600 as the cumulative materials used. Let's go back. If we use 15,000 units of materials, we are going to produce 1,500 units of table A. So the output is 1,005. And the third table on the ranking is table C. So that is the third one. So we have table C. The remaining materials now is 35,000. And the total material requirements for table C, according to the schedule we earlier prepared, is 20,000. So we are going to subtract 20,000 from 35,000, and that gives us 15,000. so that cumulatively now we've used 44,600. If we use 20,000 of materials in manufacturing product or table C, we are going to produce a total of 2,000 units. Then the last table on the ranking is table D. Now the remaining materials is 15,000. And because we only have 15,000 left, the maximum we can use is the same 15,000. So that the remaining materials will be 0. And now the cumulative materials used will become 59,600. This is the total number of materials available. Okay. So let's refer back to the determination of total material requirement schedule. We realize that table D has a demand of 2,000. And the total material required in respect of table D is 24,000. Okay. So in order to meet the demand of 2,000, we require materials of 24,000 to produce table D. But in our optimum production schedule, we are saying we are going to only use 15,000 because that is the only amount of materials remaining. So we can use ratio and proportion to determine the output that we produce for table D. This is done. So we can say that if 24,000 kilograms, so that is the total that is required, is equal to 2,000. 2,000 units is the maximum demand. Then 15,000 kilograms, that is what we are made to use now, will be equal to the 15,000 kilograms divided by 24,000 times 2,000. Okay, and this will give us a unit of 1,250. This is the output we can produce in respect of table D, given our limiting factor. So we have 1,250. So this is the optimum production plan based on the limiting factor. We are going to produce 1,200 units of table A, 1,500 of table C, 2,000 for table C, and then 1,250 for table D. The second question requires us to determine the contribution, the total contribution. So we have computation of total contribution. From production mix. Okay, so we have type of table. We have our output. We have contribution per unit. And total contribution. This is in Ghana cedis, and the output is in units. Okay. So according to our ranking, we are going to produce in this order: B, A, C, D. In respect of table B, according to our optimum production plan, we are going to produce 1,002. For table A, we are going to produce 1,005. C 2,000, and D 1,250. Per our computation of contribution per unit, we realize that table B has a contribution of 250, table A 300, table C 190, and table D 120. So in order to determine the total contribution, we multiply the output by the contribution per unit. So in respect of table A, table B, we have 300,000. For table A, we have 450,000. We have 380,000 here. And finally, we have 150,000. So we are going to add up. When we sum all of them up, we realize we have a total contribution of 1,280,000. So therefore, total contribution based on our production plan is 1,280,000. Okay. The question also tells us to determine the maximum profits if Okokroko incurs fixed cost of 800,000. So we have determination of maximum profits. The maximum profit is determined by subtracting the fixed cost from the total contribution. So we have contribution minus fixed cost. Per our calculation, we have total contribution of 1,280,000, and total fixed cost as given in the question is 800,000. And so when we less 800,000 from 1,280,000, we have a maximum profit of 480,000. This is the maximum profit Okokroko Company Limited can make. Finally, we are told that because we are not able to meet demand for table D. You see, in table D, we couldn't produce the total demand. The total demand for table D was 2,000, but we are only able to produce 1,250 because of the limiting factor. And there's a supplier who says he's going to offer each table at a price of 180 Ghana cedis. As a management accounting consultant, you are expected to advise Okokroko Limited whether to accept this particular offer or not. Okay. The selling price for table D. Table D is the table whose demand we couldn't fully meet. Okay, the total requirement is 2,000, but then we are only able to produce 1,250. So to make up for that particular difference, this supplier is saying he's going to supply each table at a price of 180 Ghana cedis. Should that offer be accepted or not? That offer should be accepted or not by comparing the selling price to the contribution. By comparing the selling price to the variable cost. Okay, we have the selling price of table D to be 260. And the supplier is saying he's going to offer a price of 180. So it means that if we buy it from the supplier at 180, we can go and sell it at 260. Okay, when we buy it at 180 from the supplier, we are going to sell it at 260. That is, we are going to get a contribution of 80. That means you have to accept it. So for III, because the supplier is giving you a price of 180 per unit of table D, and the selling price, so we have selling price. The selling price per unit of D, the selling price per unit of D is 260. And then he is offering to sell each unit of table D at a price of 180 Ghana cedi. That is the cost to Coca-Cola Limited. So, variable cost, which is the supplier's offer. $180. If Coca-Cola accepts this offer, is going to make a contribution of 80. Since Coca-Cola Limited is going to earn this particular contribution, it means he should accept the offer because he will be able to use this contribution to cover any fixed costs available. Is it alright? Okay, so this brings us to the end of the tutorial on limiting factor analysis. Thank you for watching, and if you haven't subscribed yet, please I entreat you to subscribe to the channel, and also don't forget to hit the notification bell so that anytime I upload a video, you get notified. Thank you and stay blessed.